In this video, we will talk about estimating limit of quantitation. So generally, limit of quantitation approaches can be divided into two groups. First group is where trueness and precision are estimated at different concentrations. And the second group is where estimating limit of detection is related to estimating limit of quantitation. So the first group is more preferable because their precision and trueness are really estimated, and therefore this approach estimates limit of quantitation by its definition. However, this is more labor intensive. Here, different relevant guidelines or standards set the minimum precision and trueness limits that have to be achieved at the limit of quantitation. Also, it has been suggested that uncertainty can be estimated at different concentrations, and from that LoQ can be estimated. So in the second group, most of the times the same data can be used to estimate limit of detection and limit of quantitation. However, the difference here is that the k-value, which in LOD is taken from student coefficient, is different. For example, if we are estimating LOD, we can take the k-value as 3.3, but in case of limit of quantitation, we can use the value of 10. Here, however, trueness and precision are not estimated, and therefore we can very easily over or underestimate the capabilities of the method. Also, it has been suggested that signal-to-noise ratio and visual evaluation can be used to estimate LoQ. So, which approach should we use to estimate LoQ? Well, the choice depends on the importance of LoQ parameter for that analytical method. However, when it is really necessary to follow a specific guideline, then these suggestions in that guideline must be followed. However, our recommendation is that if LoQ is really critical for the analytical method, then the first group of approaches should be used so that precision and trueness are really estimated at different concentration levels. Otherwise, we suggest using the approach that is suggested by ICH, that uses the standard deviation of the residuals. So also let's look at some important aspects of LoQ. First, where is LoQ used? First, it can be used as concentration where above we can say that if the sample concentration is above LoQ, then the sample can be quantified, and this accuracy for this quantitation is fit for purpose. The second use is for characterizing the analysis method. However, it should be noted here that whenever LoQ is used, the approach that was used to estimate LoQ should also be stated. As with LOD, also with LoQ, the data that is used to estimate it should be in range of LoQ, and matrix matching samples must be used. Also, as LoQ changes between days and measurement series, then we suggest that LoQ should be estimated on 5 different days, and the highest LoQ value should then be used for the analysis method. As a last note, for approaches that use the calibration function, also linearity and stochasticity of the data must be taken into account, again similarly to limit of detection. So hopefully this video has given a better idea how to estimate limit of quantitation.